Okay, on number 3, we've got air pumped into a oh my gosh! Okay, we've got air pumped into a spherical balloon at a rate of 800 cubic centimeters per minute. How fast is the radius of the balloon changing at the instant the radius is 30 centimeters? Okay, so here's what we know. We've got a balloon. We're filling up its volume. All right, and so we've got our drawing over here. So there's a radius there. Eee. Okay, it's supposed to be spherical. All right, so we know the volume of a sphere is 4/3 power cubed. 4/3 power cubed. All right, and we are given, it says air is being pumped in, so we're told the rate in which that volume's changing. We're told the dVdt. It's 800 cubic centimeters per minute. Okay, and then it says how fast is the radius of the at 30 centimeters. All right, so it's asking us then for dr dt when the radius is 30 centimeters. All right, so there we go. So here we go. So step 1, take the derivative with respect to time. So that's dv dt. All right, and that's going to equal 4 pi r squared dr dt. 4 pi r squared dr dt. Awesome. And then, so that's good. And then on step 2, we substitute in and solve. All right, so step 2. All right, dv dt at that moment we were told was 800. And now the units work themselves out again, but this time I'm not going to include them until the end of the problem. And then we've got 4 pi. The radius is 30. All right, so it's going to get kind of big here. It's okay. And squared. Yeah. And then dr dt is what we're trying to solve for. All right. So all we got to do is divide. I'm sure it'll reduce. We're going to have a pi in the denominator. All right. And this is the rate in which the radius is changing. So that's going to be a linear unit. Like the what happens here is this is going to be a centimeter squared. This has got a centimeters cubed. So when I divide them, I'll just have centimeters. All right. So what is this? Calculator here. So it's 900. Let's bring up calculator. There you are. All right. So 900 times. So it's going to be 800 divided by 900 and then times 4, right? And then also a pi will be in the denominator. I'll just throw it down there. And let's math 1 that, so it'll just go ahead and reduce for me. 2/9. Okay, all right. Yeah. All right, so it's 2/9 with a pi in the denominator also. All right, so I'm dividing both sides by all of that. I did do 4, didn't I? Yeah, that's fine. All right, so it is 2 over 9, but that pi is in the denominator too. So let's just leave it that way. And this will be centimeters per minute. Yeah, I think that's fine. Leave it like that. I mean, 2/9 is 0.2 repeating. I think it's just best to leave it as the fraction.